Welcome to Get Your FRQ On. This is from the Calculus AB exam, 1999, question 4, and it is a calculator active question. In the question stem, we're provided some information about a function f at x equals 0. We are given a value of f of 0, f prime of 0, and f double prime of 0. And then a new function g is defined in such a way that we only know an explicit rule for g prime of x, and then these four parts of the question follow. First, write the equation of the tangent line of f when x equals 0. Well, in order to write the tangent line of f when x equals 0, we need to know three things. We need to know that we're interested in x equals 0. We need to know the value of f of 0, and then we also need to know the slope of the tangent line at x equals 0, which would equal f prime of 0. Right? We're given in the question stem that f of 0 is 2 and that f prime of 0 is negative 3. And it turns out this is all the information we need. We already know that we're interested in x equals 0. We're given the value of f of 0, that's 2, and we're given f prime of 0, that's negative 3. So we would just take this information and put it into point-slope form. So the equation of the tangent line of f when x is equal to 0 would be y minus 2 equals negative 3 times x minus 0. And there's a number of different correct ways to write the equation of this line. You don't have to have it in point-slope form, but one of the things I would recommend is once you have a correct equation and in an acceptable form, save yourself the time, move on. Just leave it as is. In part B of the question, we are asked to determine if there is enough information to know if f has an inflection point when x is 0. So about inflection points, we know that the graph of f will have an inflection point at x equals 0 if f double prime of x is 0, if the second derivative at x is 0, and in this case at 0, and would also have to change sign. If f double prime of x does not change sign when x is equal to 0, f will not have an inflection point at x equals 0. So we have to determine that. Well, is f double prime of 0 0? And if so, do we know somehow whether or not f double prime changes sign at x equals 0? Right. We are given that the derivative, the second derivative of f at 0 is 0, so the first part of our test is met. F double prime of 0 is 0. But there's no information in the question stem that allows us to conclude whether or not f double prime changes sign at x equals 0. We just don't have that information in the question stem. So is there enough information to determine if f has an inflection point when x is equal to 0? No, there isn't. So when you answer a question like this in a free response question, there's a couple of things you're going to want to remember. First, whatever calculus you use to make this determination, make it explicitly clear what you're doing. Once you've done the calculus, make sure that you answer the question being asked. The question is, can it be determined if f has an inflection point when x equals 0? That's a yes or no question. So in addition to doing the calculus to support or justify your answer, you do have to provide an answer. So a complete response to a part of a free response question like this would include an explicit statement about, yes, we can determine if f has an inflection point because, or no, we cannot determine whether f has an inflection point because, whatever the justification is. So make sure that when you answer a free response question, you make sure to answer what's actually being asked. You have to support it with calculus, but you still need to answer the question. In part C of the question, we are given that the function g, whose derivative we are told in the question stem has the property that g of 0 equals 4, and then we are asked to write an equation of this tangent line of g when x is equal to 0. Okay? So we're given the derivative expression for g in the question stem. It's kind of a complicated expression, but we're also substituting x equals 0 in, so that makes the arithmetic much easier. G prime of x is given to us as e to the negative 2x times the group 3 times f of x plus 2 times f prime of x. We know we're substituting x equals 0 in. We know from the question stem what f of 0 is, and we know from the question stem what f prime of 0 is. So we're just going to substitute all of that information into g prime to determine g prime of 0. So we substitute in x equals 0. We are given that g of 0 is 4. We know that f of 0 is 2. F prime of 0 is negative 3. So we just put all of that in and simplify. It turns out this arithmetic works out rather nicely. G prime of 0 is just 0. So the equation for the tangent line we can write in point slope form. We know we're talking about x equals 0. We know g prime of 0. We know g of 0. Put it all together. We have y minus 4 equals 0 times x minus 0. This is the same as saying that y is equal to 4. The tangent line is horizontal at x equals 0 for g, which is fine. You do not need both versions of this equation. Either one would suffice. For most questions like this, writing it in point slope form makes a lot of sense because most of the time we would not expect the derivative to be 0 or x equals 0, and so we just get a horizontal line. But in this case, it is a horizontal line, so whether you have y minus 4 equals 0 times x minus 0, or y equals 4, or maybe even have y minus 4 equals 0, any of those equations would be acceptable since they are all correct. In part D of the question, we are given an expression for the second derivative of g, and we are asked to verify that this is in fact the second derivative of g. Keep in mind we are given in the question stem an explicit formula for the first derivative of g. So really what this question is having us do is apply differentiation rules to get the second derivative of g using the first derivative of g. And then we have to answer the question, does g have a local maximum at x equals 0? And like most questions like this on a free response question, we will need to justify our conclusion using the language of calculus. All right, so we are given a formula for the first derivative of g in the question stem, so all we're really going to do in this first part is apply differentiation rules and see what we get. Can we make it look like the expression we're supposed to verify is the second derivative of g? So the first derivative of g is e to the minus 2x times 3f of x plus 2f prime of x. So we're going to use some product rule for sure here. We have e to the minus 2x times a group. So if we use the product rule on this, g double prime would be e to the negative 2x times 3f prime of x plus 2f double prime of x. Fortunately, this is a sum, and we don't have to worry about any chain rule in the middle of this. And then plus negative 2 times e to the negative 2x times the original 3f of x plus 2f prime of x. And then the negative 2 in the addition, we would just write that probably as subtraction. So we have something to start with, and all we're really going to do here is combine like terms. Yeah, it looks a little bit more complicated than like Algebra 1 level combining like terms, but that's really all it is. We combine the like terms. So we multiply all this out, we see what we get, and yes, it does in fact equal e to the negative 2x times negative 6 f of x minus f prime of x plus 2f double prime of x. Now the question is, does G have a local maximum at x equals 0? And then provide justification. Well, we have a couple of options at our disposal. We know we can find G double prime of 0 now because we just found a formula for the second derivative of G. If we plug 0 in for x, we get e to the negative 2 times 0, which would be e to the 0, that's just 1, times the group negative 6 f of 0 minus f prime of 0 plus 2 times f double prime of 0. Substituting all of those values in, we find that the second derivative of G evaluated at 0 is negative 9. Now, since G double prime of 0 is negative, we can conclude that the graph of G is concave down at x equals 0. We also saw in part C that the first derivative of G, evaluated at 0, is also 0. So we know that at x equals 0, we have a critical point of G of x. By the second derivative test, G of x does have a local maximum at x equals 0. Now, questions regarding first derivative test and second derivative test show up frequently in free response questions. However, you typically don't have to refer to them by name. I did because I like to provide thorough responses. But for the student, really what you would have to worry about is, did you conclude that G double prime of 0 is negative and that this means the graph of G is concave down there? If you did, great. Did you refer to the fact that G prime of 0 is 0 in this part of the question? It's not enough to have successfully done it in part C. You must refer to it here as well. If you do that, G is concave down at x equals 0, G prime is 0. You can conclude that G of x has a local maximum at x equals 0 without naming the second derivative test. Typically, you don't have to name theorems or tests. You just have to actually do what they say to do. So keep that in mind as you're answering free response questions that ask you to justify your conclusions. It's typically not the name of a theorem, property, or test that they're interested in. It's the calculus behind it. Do the calculus. Make absolutely certain of that. If you remember the name of a theorem or test or whatever, maybe you include that in your justification. But the name itself typically is not going to get you any points or cause you to lose any points. It's the calculus and whether or not you've done that correctly that will matter.